dynamic valve timing check using the 4823, so the Pico scope, 8-channel scope. This is a classic example. This is bringing to a close a case study that we attended earlier this year. So it was a quad cam engine V6 with a fault code for, I think it was bank 1 camshaft correlation. So again, it required a dynamic valve timing check because the vehicle runs fine. It's just that within a few miles of driving the vehicle, warning light comes on to inform the customer, the driver, that there's a problem. Now, the mechanical inspection of the timing was there or thereabouts. It was a difficult call. You could, depending on whether you took the slack out of the chain or whether you just eased on the crank a little bit, you could convince yourself that these marks were in line. But using the dynamic valve timing check, so that's all cams against crank and an ignition signal, we were able to plot the relationship between cam and crank, measure the deviation. So as we've got here, you see we're connected. We're using 6 channels because we need 4 for cam, 1 for crank, and then ignition trigger for number 1 cylinder. The vehicle is now repaired, so this is our post-repair capture. And now I'll narrate over the waveforms and explain how we measure the deviation and how we've conclusively proven that certainly the engine had to come out, be dismantled, and we could concentrate certainly on the relationship between the camshafts on bank 1. Hello and welcome to the quad cam case study on the Toyota Camry. This is using the 4823 scope, and here's the capture, the initial capture. This is test 1, idle, VVT disconnected. I've called it study there. This is 6 of the possible 8 channels utilised to look at valve timing or cam and crank correlation. And as you can see, it's quite a mess at the moment. I've left the properties page up here. That kind of just explains what's going on each channel, whether there's any filtering activated. So if I was to just filter here, you'd see there it informs the user of any filtering. So we'll cross that off, or we'll close it off because that's not required. We'll keep these up for now, but should you need more space for analysis, then obviously just minimise or even close. But what I like about this, it tells us exactly what we connected to, camshaft, but more importantly which bank and which cam, because you can really get in a mess with these measurements if you've not been disciplined enough to get these labelled up. So first tip is to right click and auto arrange axis. That puts everything in a bit more clarity. Explain here that this is bank 2 exhaust, bank 2 inlet, bank 1 exhaust, bank 1 inlet, and this is IGT, so this is the ignition trigger signal from the PCM engine ECU to the coil pack. So that would be your coil charge time, if you like, and then at this point here we'd have our secondary ignition event. So we're using that as our synchronization signal. So let's just grab a couple out the center here. Let's look at this and let's try and get a little bit more purchase, if you like. If we bring these all up to 0.5, we'll just increase the range of these waveforms so as we can see a little bit more detail, because the auto arrange axis feature is great, gets it all in line, but yeah, you end up with very small axes sometimes. So we'll keep these in colour order as well. So we go down to, let's keep that as yellow there. Perfect. Okay, and let's get a little bit more on the crank, because everything is linked to crankshaft. Let's just put a little bit of filtering on the crank as well. You'll notice that with the 4823, all the features are the same within the software. It's an 8-channel scope, but things like channel options, probe settings, they're all the same. They're all in the same location. So for your options for F, G, H, etc., they would be exactly where they are for A, B, C and D. Okay, so we'll choose this this point here on the crank, and let's zoom in for as much accuracy as we can. will go probably midway through there. Okay, and then 720 degrees later at the same spot, so there's one crankshaft revolution, there's 2 revolutions. And let's just go a little bit more for accuracy, try and get that passing through the middle. See how that falling edge there is not the vertical edge you might imagine, especially when you zoom in. The Picoscope can capture that and show you that. Right, and I mentioned in the case study how we're going to choose the first rising edge from each camshaft. So this is one here, here, here and here. You see they come down in like a step fashion, and we're using IGT at this point here, so approximately 1, 2, well, let's zoom in rather than struggle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 teeth after the missing tooth of the crank. So using IGT as our reference there, we count those teeth. We know that from this will be our measurement point, our reference point on the crankshaft, and not this one here, because here we have our tooth count, and here we have from this point to IGT a far greater tooth count. So let's bring out the time rulers then. Let's make sure nothing's changed here. That looks good. That looks good. So time ruler number 1, and if you remember on bank 2 there wasn't any problems in the case study. I think this tallied perfectly well with the donor vehicle. We'll qualify this. Okay, so keep a mental note of these if you can. We are 94 degrees on bank 2 inlet and 6.5 degrees of crankshaft rotation on bank 2 exhaust. And then of course we move on to, let's go bank 1 exhaust. That's this one here. First rising edge, remember, after the missing tooth. It's approximately 190, and this one here, I think this is around about 224. Let's bring that back again. Yeah, 190 and 224. Alright, so that's the technique. Yeah, the first rising edge after our measurement point here, using IGT to denote which of the missing tooth or missing teeth we're going to measure from. Okay, so this helps us identify the missing tooth as our reference, our clock signal if you like, our point of initial measurement, and then the first rising edge of each camshaft. Yeah, well, that's a falling edge after that point. The first rising edge is this one. Same again, there's a falling edge. We'll go for the rising edge. So remember, you've got those values there. Next is we go to the donor vehicle. We'll open our donor vehicle now. So it's a quad cam case study. And here's our donor. Now this was a known good vehicle. Again, to keep things simple, make sure that we use the same colours for each measurement. Looks like I've got this already marked out here, but we will check this. So ignore those for a second, those are our notes from the previous one. Although, actually no, we'll keep them because they do refer to the donor. Sorry, the customer's faulty vehicle. All notes above are from the problem car. This is the press center donor VVT disconnected. Okay, that's quite valid. Remember, let's try and get a bit more purchase on these. Okay. So yeah, these are in completely the wrong position. Remember, we want to go for the missing tooth. at this point here, don't we? Because we've counted the number of teeth to make sure that we're using the correct TDC, sorry, not TDC, missing teeth on the crank. Let's put some filtering on there. Just so as we get a nice crisp edge on the crank. Okay, there was our TDC, and we were through the centre there, weren't we? Not TDC, I keep saying TDC, do apologise. It is our engine reference point, crankshaft reference point. That's not TDC. It might be all pistons in line, it might be pistons 10 degrees before top dead centre. You'll have to refer to the manufacturer's specifications for that. Okay, notice this additional noise on this waveform, and it looks as though the donor may have been on direct injection because the amount of noise increases from when you go from port injection to direct injection, because if you remember the donor was RX 350 hybrid, I think it was. Yeah, so again, not too fussed about that, but just bear in mind. So yeah, make sure we got the right point on the crank. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there we are. Okay, remember this can shift slightly because it's an ignition timing event. This will not shift, okay, but this can because of advance and retard. So we'll forgive that if it's not quite bang on. Nevertheless, we know that it's this point to measure from. Certainly not this one, because IGT after this point is all the way over here for cylinder 1. Okay, so again, first rising edge, excuse me, after crankshaft reference point 6.83, while the donor was 6.3. Excuse me. Next was first rising edge on bank 2 inlet, 94.27. We're in the ballpark there. Next then, this is where we started to find some evidence, and was I grateful for that. So first rising edge on bank 1 exhaust, 184, 191 there. There's an error immediately. And then the final one, at this point here, let me try and zoom in so as we don't struggle. Yeah, 216 in comparison to 224. So at this point in time, there is a clear difference, isn't there, between bank 1 exhaust and inlet on the donor vehicle with VVT disconnected. Remember, that's critical. So remember comparing apples with apples. This is the donor vehicle. There is a discrepancy most certainly here. Bank 1 exhaust, bank 1 inlet. Just verify that again, yeah. 216 on bank 1 inlet, which is this one. 224 there. Here was 184 against 191. So there was our discrepancy. That gave us the evidence that we required now to dig deeper and find out why we should have a valve timing shift with VVT disconnected on just one bank only. So I thought I'd just show you this. This is test 8, the donor vehicle, and this is now VVT connected. And I've included here the details within the case study. So this was the customer vehicle, this was the donor vehicle. These are the calculations of error in terms of degrees of crankshaft rotation, divide by 2 to give you camshaft. Just looking first of all now, VVT reconnected and all fault codes erased at idle speed. We've got 6.857 on bank 2 exhaust. Well, bank 2 exhaust 6.4 there, 6.4 there. So there's some movement. Okay, so worth noting. And 6.4, 6.8, so that's in the retarded direction. Okay. So same measurement criteria. Remember this reference point here on the crank and here, using this as our sync. Next up then is bank to inlet. Let's get that in position. Bank to inlet returns 91.49. Bank to inlet on the customer vehicle 94. So there's a difference there. On the donor 93. And now we've got VVT intervention, and that has advanced timing because it's now 91 instead of 93 or 94. Next measurement will be bank 1 exhaust. And here we are, 184. So bank 1 exhaust on the donor vehicle 190. Sorry, on the customer vehicle 190, on the donor 184. So it looks as though on bank 1 exhaust there has been minimal or virtually no intervention of VVT. So that is in its default position. And then final one is bank 1 inlet. Okay, here we are, 213.5. Bank 1 inlet was 224, 216. Most certainly we've got VVT intervention now, 213. So that's advanced valve timing on that cam. So this is all about being aware of VVT intervention, stopping it happen if you're going to do cam and crank correlation, because that could have really had you over had you been looking for comparisons between vehicles without disconnecting VVT. Alright, I hope that helps. Thanks for listening. Take care. One of the key points to remember looking at VVT control and when you're looking at cam crank correlation is to disconnect VVT controllers. So however they are, however they function, whether that's hydraulic or electrical. On this one we can disconnect each one. It's a simple plug on the front of the controller. We know then that the camshafts return to their default position. And then from there we've got a benchmark to work to. So remember, if you're doing a comparison, VVT controllers disconnected so that the cams return to their default or rest position, whether that be full advanced, full retarded. You'd have to refer to the manufacturer features for that information. Once you've done that, then you're comparing apples with apples. So this is your faulty vehicle with the cam correlation, VVT controllers disconnected, against your good vehicle, your donor vehicle, whatever it may be, or post-fix. Once you've captured that event, post-fix, again, ensure that you are keeping variables to a minimum, VVT controllers disconnected.